Hello everyone, my name is Luqman Azri. I will present about Chapter 8 Advanced Counting Technique. Let us begin with the recurrence relation definition. An equation that defines a sequence based on a rule that gives the next term as a function of the previous term. For example, AN, a recurrence relation for the sequence is an equation that expresses AN in terms of one or more of the previous terms of the sequence. The previous term is A0, A1 and up until AN-1. For all integers n with n greater or equal to n0, where n0 is a non-negative integer. A sequence is a solution of a recurrence relation if its term satisfies recurrence relation. The initial conditions for a sequence specify the terms that precede the first term where the recurrence relation takes effect. So I will explain about the application of Tower of Hanoi. Tower of Hanoi consists of 3 roads and the puzzle begins with the tick stack on the road in order of decreasing. The goal of this puzzle is we need to move the entire disk to the last road. There also has a rule that we need to obey. Only one disk can move at a time. Larger disks cannot be replaced on a smaller disk. This only can be moved on an empty or a larger disk. Let us move to the explanation. Let Hn denote the number of moves needed to solve the Tower of Hanoi problem with n disks. Set up a recurrence relation for the sequence Hn. The first figure shows that Hn and the second figure shows the Hn-1. Solution: transfer the top and -1 disks to the pack 2 using Hn-1 move. Second step, transfer the larger disk to the third pack. Last step, transfer back the n-1 disks to the pack 3 using Hn-1 additional move. To sum up, step 1 using Hn-1 move, step 2 using 1 move, and step 3 using Hn-1 move. Hn-1 is repeated twice and the largest disk is moved once. These 3 elements is actually equal to Hn. The combination of this step derives recurrence relation, which is Hn equal to Hn-1 plus Hn-1 plus 1. And will end up as Hn equal to 2Hn-1 plus 1. This is the recurrence relation which we will use to determine the final closed formula. The explanation is not over yet. We still have to solve the recurrence relation, so we need to use closed formula. So what is a closed formula? Closed formula is a formula for the n term of the sequence generated by a recurrence relation. There are 2 different methods, which is working upward-forward substitution and working downward-backward substitution. For the Tower of Hanoi, we will use method 2. So how it works? We can use iterative approach to solve this recurrence relation. We have to use recurrence relation repeatedly to express Hn in terms of previous terms of the sequence. In this sequence, the previous term is Hn-1. By applying the same theory of the recurrence relation of Hn-1 is equal to 2Hn-2 plus 1. After a few steps of calculation, Hn is finally equal to 2 square Hn-2 plus 2 plus 1. After that, we repeat again with the same theory. A few steps of calculation is done again to find the result of Hn in terms of its previous term. Then we get 2 cubed times Hn-3 plus 2 square plus 2 plus 1. Process is repeated for several times. In the next last equality, the initial condition H1 is equal to 1 has been used. This is because only 1 move is needed to transfer 1 disk. The last equality is based on formula for the sum of the terms of geometric series. So the final answer is 2 power of n-1 is found as the closed formula. In conclusion, we have covered the definition of recurrence relation and the application in Tower of Hanoi. That's all for me. Thank you for watching.